Let's start looking at some homework problems from section 5.7. Let's look at number 11. We have the integral of t over the square root of 1 minus t to the fourth. Now, if you look at this form, this matches nicely with the arc sine rule, with the constant with the square root in the denominator, with the constant coming first being positive, that's the a value, or that's associated with the a value, and the variable coming second with the negative in front, so that matches up with our arc sine rule. The next step is we need to rewrite this in the form that will match the denominator in terms of the exponents. We need the squared to show up in our original problem, so we're going to force that to happen by first setting the parentheses squared and then the second term being parentheses squared. Now we need to adapt the value inside so that we can have the same problem. We can keep the value of the problem without changing the value. We just want to change the form. So if I have parentheses squared, I can put 1 inside because 1 squared is equal to 1. That's not changing anything. Parentheses squared, now I need to adapt the t to the fourth. So I can put t squared inside the parentheses, because if I multiply this through or expand this, t squared squared multiply 2's, that will give me 4. So we have something that we can now use to help us find our a and u value. Our a value is what's inside the parentheses, so that's 1. Our u value is what's inside the parentheses as a variable, so it's t squared. Again, your a value is always going to be a constant value. Your u value is always going to have a variable inside of it. Okay, let's find the derivative. Our du over dt is simply 2 times t. To find dt, which is du over 2t. And we can start making our substitutions. Initially, our t value is going to stay square root of a squared minus u squared. Dt gets replaced with du over 2t. Okay, and we see that the t's will cancel out for us. And we can pull this 2 out in front of the integral sign. So 1/2 times the integral of du over square root of a squared minus u squared. Okay, we already said that this matches with our arc sine rule. So our rule is simply arc sine of u over a plus c. We do need to keep the coefficient, so we pull the coefficient in front. 1/2 arc sine of u over a plus c. So that's our solution there. All right, 13. We have the integral of e to the 2x over 4 plus e to the 4x. And if you look at this form, this is going to match with our arctangent rule because we don't see a square root in the denominator. But we do need the denominator to match in form with the integral rule. So we need this to have parentheses squared. We need this side to have parentheses squared. So I'll go ahead and just put the parentheses there in place with the square on the outside. We want to adapt the first term, so we're going to make the 4 into a 2 so that we have 2 squared here, which equals 4. And then we want e to the 2x inside, because we know 2x times 2 is 4x, and that will match with our original problem. Okay. A nice thing about having the parentheses show up is that now we can simply look inside the parentheses, and that will identify our a value and u value. A value is the constant, so a is 2. Our u value has a variable inside, so e to the 2x would be our u value. So we need to find the derivative, du over dx. E to the u becomes e to the u times u prime. So I can pull the 2 in front, solve for dx, so dx is du over 2e to the 2x. And I can start making my substitutions. E to the 2x stays initially. A squared plus u squared. Dx gets replaced with du over 2e to the 2x. The e to the 2x cancels out. The 2 can be pulled out in front as a coefficient. And now we can simply apply the rule for arctangent. So arctangent is 1 over a arctangent of u over a plus c. Now in front of the 1 over a, there's the coefficient that we still need to keep track of. So this 1/2 is outside the rule. So 1/2 times 1 over a arctangent of u over a plus c. The 1/2 times 1/2 gives us 1/4. So we have our solution there. 15. Integral of 1 over square root of x times square root of 1 minus x. Now seeing that there's a square root outside, or a value outside the square root with multiple values inside, this may look initially like the arc secant rule, but this actually is going to match better with the arc sine rule, because the constant, the a value, is the positive term and the u value is the negative term. The arc secant requires the u squared first, followed by the constant next. So this is actually going to be the arc sine rule, and this square root of x is actually going to cancel out once we make our substitutions, once we find the derivative, and once you convert everything to be in terms of a and u. So if we want this to match the arc sine rule, what's inside the square root needs to be parentheses squared and parentheses squared. We need the exponent squared to come up. So I'm going to go ahead and set that up, parentheses squared, parentheses squared. The 1 will remain as 1 inside. However, I need to adapt the x so that I have parentheses squared having the same value as this x. So I would have to have what's inside the parentheses as square root of x, because square root of x squared is equal to x, and this allows us to have the form that matches our rule for arc sine. A value is what's inside the parentheses, which is 1. U value is what's inside the parentheses, which is square root of x. So if u is square root of x, I need to find the derivative, and to find the derivative, I can first write it as a rational exponent, x to the 1/2. We go through our power rule, bring down the 1/2, subtract 1 from the exponent, clean it up, we get 1 over 2 root x. Solve for dx, we get dx equals 2 root x du. Okay. We make our substitutions. This square root of x stays, and we have square root of a squared minus u squared. Now, we don't want to replace this square root of x with the u value, because if we did, then we would have 1 over u times the square root of a squared minus u squared, and then this isn't going to match a rule that's available to us with one of the 3 rules available to us, and we need the square root of x to cancel out. So we're going to leave the square root of x here. dx gets replaced with 2 root x du. The square root of x cancels out. Pull the 2 in front. So now if you observe what you have left, this matches perfectly with our arc sine rule. Okay. So we simply apply the arc sine rule, which is arc sine of u over a plus c, and the 2 is a coefficient, so that needs to come out in front, and we have our solution being 2 arc sine of square root of x plus c.